Okay, good evening to everyone. Good evening and welcome to another new video. So today we are going to look. Today we are going to. Today we are going to look one question on maths mechanics. It's June 2020 paper 3 question 4 on ladders. So the question says that the foot of a uniform ladder of length 2a and weight w rests on a rough horizontal ground, and the top of the ladder rests against a smooth vertical wall. The ladder makes an angle of 60 degrees with the horizontal. A man of weight 4w climbs up the ladder, given that the ladder begins to slip when the man has climbed 2/3 of the way up the ladder. Find A, the coefficient of friction between the ladder and the ground. B, how far a boy of weight 2w can climb up the ladder before it begins to slip. So, firstly, firstly, those are just key things we need to take note in solving ladders problem. Firstly, when you want to solve maybe a question on ladders or any other question in math mechanics, maybe except or even all the question in math mechanics, you need to draw before having an idea on the question. So when you are drawing the diagram, it is for you to have for you to have a clearly manipulation, an easy manipulation of the question. So once you are drawing a diagram, you have a clearly manipulation of questions. Okay, the second part is just that when you see in a question that you have mentioned just that the ladder is resting on a rough horizontal ground, it just simply means that the force is taking place in that particular direction is a frictional force. The third point there is that what if maybe the question you have just mentioned that the ladder is resting on a smooth vertical or horizontal ground or wall, it just means that there's no frictional force that is taking place there, which means that the frictional force that is acting at that point is zero. The third, the fourth point there is just that the fourth point there is what finally we just need to resolve the forces and moment. That is just all about ladders. You should take note that the when you have a force, so the first thing so you have to recall that the when you have a vertical force that is acting downward, means that you need a perpendicular distance that is acting horizontally. Yeah, that's acting horizontally. So you can now maybe recall the definition of a moment. A moment of a force is defined as the product of a force and the perpendicular distance from the line of action of the force to the pivot. Okay, here you take note that you're having a vertical force. It means that I need a horizontal distance. I need a horizontal distance. And then if I need a horizontal distance, it means that what I'll use a cos trigonometric function. So my perpendicular distance d will be equals to what? Will be equals to a, which is the distance from the weight of the ladder and the ground, times the trigonometric function, since it's acting horizontally, which is what? Cos 60 degrees. Now I have now the distance, and now multiply, since moment is equals to what? The force times perpendicular distance. So the force here is W. So I have W times A equals 60 degrees, as you are seeing from above there. Okay, for the man it's just the same thing. It has a vertical force, so you need a horizontal perpendicular distance. So the distance covered for the man to the ground is 4/3 a. So from so my distance here I have what? The distance I have what? 4/3 a. Since it needs a horizontal perpendicular distance, it means that I will use a cos trigonometric function. So I have what? Times cos 60 degrees. This is the distance covered by the foot for the of the man in that angle. So you just multiply by the force to have the moment about that point. Then now that is just all about the clockwise moment. Then now for the anti-clockwise moment, you realize that this is my anti-clockwise moment. Why is that I'm not using the frictional wall here again? It's just that the frictional force of the wall here is 0 since it is smooth. So I'll not take note of this part here. So I'll just take note of the frictional force, the normal reaction force of the wall. So you realize that the force here is acting horizontally, so we need a vertical perpendicular distance. Since it needs a vertical perpendicular distance, it means that the trigonometric function that we shall use there is a sine trigonometric function. So the distance acting at that angle be what? The distance, first of all, from the normal reaction force of the wall to the ground is 2a times the trigonometric function at that particular angle, which is what? Sine 60 degrees. So we have now the distance just multiplied by the force. Since you now multiply by the force, that will be our anti-clockwise moment. So now you just equate. As you are seeing from above here. When you sum in moment, yes, equals to. So this moment says that what? The sum of clockwise moments equals to the sum of anti-clockwise. Okay, so if I simplify here, you realize that I've divided all through by a cos 60 degrees on both sides. So cos 60 degrees you cancel here, a cos you cancel here. Then now I've divided by what? Cos 60 degrees. So sine 60 degrees on cos 60 degrees give what? Tan 60 degrees. Okay, RW is given by what? 5W, the equation of friction between the ladder and the ground, times 2 tan 60 degrees. So 2 times 5 you get what? 10W, the coefficient of friction times 60 degrees. Okay, so W plus 16 on 3 W. I can express our W, I can write it as 3W on 3, sorry, on 3. Yeah, it should be on 3. Yeah, on 3. Yeah, let me be 3W on 3 plus 16W on 3. So this is just the same as this one, because if I simplify the 3, it will still give us back this one. So you can simplify as you like. It's just that I want to do it just faster. So since that's the same denominator, I'll just add the numerators. So 3W plus 16W give us what? 19W on 3. So I have 19W on 3 on this side, so the W's, we cancel the W's. Now I'll now divide now, so I'll now be left with 19 on 3 equals to 10, the coefficient of friction tan 60. Tan 60 is the same as root 3, the coefficient of friction. Yeah. So if I divide all two by this, I have for the coefficient of friction to be equals to what? 19 on 30 root 3. Mind you, the coefficient is not having a unit, so I cannot leave my answer like that, but I can rationalize, because some people ask that why is that I'm having it like that. So I can multiply all two by root 3 on root 3. Just take note that the root 3 on root 3 is just 1, so it's just the same thing as this one. So I've added or I've subtracted nothing on it. So root 3 on root 3 is just a rationalized form. So you are just rationalizing times. So it's times here. Root 3 on root 3. So if I rationalize it, I have what? The equation of friction is equals to 19 root 3 on what? 30 times 3 is what? 90. Because what? If I have root 3 times root 3, root is the same as half times 3 half times, this is half a, times 30 degrees times 30, sorry. So I've add now the powers will give me what? 3 times 30 times 30. So I have what? I have 90. Yes, I have 90 as you are seeing here. But some people ask that why is that I'm having the root 3, because in the calculator you have that 1.7 something. So I'll draw a simple triangle here. I'll draw a simple triangle here. Okay. The distance between this point and this point will be 2. The distance between this point and this point will be 2. The distance between this point and this point will be 2. Okay, will be 2. Then now I need to separate the angle. Be 2. So I need to separate the triangle into two parts. Now if I separate the triangle to be 2 parts, you realize that here will be 1, here will be 1. So if I sum it, I have a distance to be 2 as the others. It's an equation. Okay. So you realize that this is the right angle triangle. So here I have what? Here the angle that is acting here, first of all you realize that on this side too is a right angle triangle. Yeah, it's a right angle triangle. So if I have 60 degrees here, mean that on this side I have what? 30 degrees. Now here if I have 30, mean that here I have 60 degrees, and here I have a 30 degrees. From Pythagoras theorem, for us to find this side here, I have what? C square is equals to 2 square minus 1 square. So I have what? C is equals to root 3. So 2 to the power 2 is 4 minus 1, 3. The square root, I have root 3. So in this side here I have root 3 here. Yeah. So now for us to have now the tan 60, I have for the tan 60, since I have tan 60, I will focus but on the angle where I have tan 60. So tan 60 will equal to what? Tan 60 be equals to opposite on adjacent from SOHCAHTOA. from SOHCAHTOA, so I'll use only this part here. So for SOHCAHTOA I have what opposite SOHCAHTOA. So I'm just depending on this angle of 60 here. So you can just also do this angle. So from SOHCAHTOA I'm having what? I'm having opposite, which is what? Root 3 all over the adjacent side, which is 1. So tan 60 degrees equals to root 3 as from above. Okay, let us continue with the B parts. Okay, the B part says simply that how far a boy of weight 2W can climb up the ladder before he begins to sleep. So the trick here is just that you should just calculate the distance. So you can just let the distance, because the distance from the weight of the ladder to the ground is A. So you don't know the distance from the boy to the ground. So that's why you are checking for. So you can let the distance from the boy to the ground be X. Okay, so resolving the forces are what? Because mind you that the trick here is just that some people will just leave the 4W here and calculate with it. So no, we are not using the 4W again. We change now. We are not using. So the 4W here in the B part is just neutral. So the RF from saying the force acting on the y direction. So the y direction positive, this one and this one, equals to the negative part. So the sum of the forces from the positive direction on the y-axis equals to the sum of the forces on the negative part. So we sum it. I have this like that. Okay. From the sum of forces on the x direction, I have what? R, normal reaction force of the wall, equals to the frictional force of the floor. So from above you have the formula, and you have the normal reaction force of the floor to be 3W. Okay, here from above I've said that I've let the distance covered by the 2W be X, taking a moment. The W here needs a perpendicular horizontal distance. Since you need a perpendicular horizontal distance, I will need a cos trigonometric function. So the distance first of all between the ladder and the ground, focusing on the weight of the ladder, is what? G first of all is equals to A, then now times the trigonometric function cos 60 degrees acting at this angle, plus now the distance. Okay, from the weight now you just multiply by the force and perpendicular distance. For the boy you just do the same thing. You have just what? It needs also a horizontal perpendicular distance. So it needs a cos trigonometric function. So the distance from here to here is X times the trigonometric function, which is cos 60 degrees, times the force, which is 2W. You now equate it to anti-clockwise moment. Since here is 0, you have what? RW times, you realize that this force is horizontal, meaning you need a vertical perpendicular distance. So you have for the distance from the normal reaction force of the floor to the ground is 2A. Since you need a vertical perpendicular distance, means that you will use a sine trigonometric function, which is what? Sine 60 degrees at this particular angle, times the distance from the normal reaction force of the wall and the ground, which is 2A, times the force, which is normal reaction force of the wall. Then now simplifying, you have the normal reaction force of the wall that you have just from calculating here. The weight we just cancel. I have now what? When I'll cancel now the weight, I'll divide also by cos 60 degrees, cos 60 degrees, cos 60 all on both sides. So I'll remain now here with A plus 2x equals to now 3 times 2 is 6. Mu is the coefficient of the geometry in the ladder and the ground. So you have just calculate. I've already calculated the coefficient of extrusion between the ladder and the ground, so you just substitute it here. Then now, if you divide all by cos 60 degrees again, you have now what? Tan 60. Tan 60 is what? Root 3. Don't forget the a part. Simplify correctly, you have 19 on 5a. Then now, now send now this a on this side here. Will now be what? Minus a. Then now, since minus a can be written as 5 on 5a, because 5 on 5 is 1, so it's just the same thing. It depends, so you can simplify in your own way. Equals to 2x. So now 19 minus 5 is just 14 on 5a equals to 2x. I divide all 2 by 2. If I divide all 2 by 2, I have what? 14 on 10a equals to x. Then now 14 on 10, and now divide all 2 by 2. I'll now have 7 on 5a, which is the distance covered by the 2 weight boy before the ladder begin to slip. Okay, thank you for watching the video. I hope it will help you.